And so our topic today is going to be building fault-tolerant, highly available and secure architectures. How hard could that be? Easy. Just do it all the time. This is a painful process, is it not? So what I'm going to try and share with you today are some learnings, some understandings and some ideas about how you can do things better. So why do things break? There are a few good reasons why things break. Facilities break. There have been some well-publicised Australian cases of data centres losing power, or I've had experiences with data centres flooding and things like that. Bad things do happen to good people. Hardware breaks, and it breaks in annoying ways. I used to work at a storage vendor, and we knew that if a particular hard drive broke and it was part of a batch of other drives, the hardware engineer knew they're all going to fail pretty soon. They're in a family, it was a bad day, maybe it was Friday afternoon at the plant, they're all going to go together. Networking. Networking is one of those things where it just is. There's the network. We're all on the network right now. And when it breaks monumentally and spectacularly. And so it can be really problematic. Code. I was once a coder. I actually started off as a mainframe coder. And I know I've done many a boneheaded coding thing that I thought was the right thing at the time. And stuff goes wrong from that perspective. But unfortunately, the biggest reason that things break are people. And I wonder if many of you in this room, like myself, remember that prickly, warm, cold feeling on the back of your neck when you're sitting there at night and you've typed something on the keyboard, you've hit enter to go do something, and you've realised, bugger, that's not going to go well. I've just done the wrong thing and there's no easy way back. I think we've all been there. So how do we protect against it? Well, fault tolerance is not a binary thing. You're not fault tolerant, not fault tolerant. It's a continuum. You need to work along this continuum. And you need to do this by automating processes. If you have a human being in the loop, you cannot be fault tolerant. Something breaks, an alert trips off. Eventually someone wakes up, rubs the sleep from their eyes, figures out what the hell's going on, tries to make a decision or escalates the decision, game over. You're done, finished. Get the humans out of the loop. The other thing is we need to test. And testing is a scary thing. Hands up here who has a highly available system or a DR plan. Yeah, you've got to put your hand up. You've got those plans. I know you've got them. Keep your hand up if you've tested it in the last 3 months. That's good. Keep your hand up if you like testing it. Yeah, thank you. You should love testing things breaking. Like Werner talked about this morning, game days. You should be breaking things aggressively because it shouldn't matter. But I'll explain to you how that works shortly. Because in the old school world, this is how we built systems. And I used to work at Veritas Software. We sold highly available systems and clustering. And this was the process. You'd go to build a brand new system, and then you would beg the CFO for budget to get another one exactly the same. And you'd have to make this case about how I need this system because it's got to be highly available, but it's not going to do any work, and it's going to cost you just as much as the first one did. Please, give me some budget. And you get two, and something goes wrong and both of them break. It just happens. If there's one thing you leave from today with, it's this. Design for failure and nothing will fail. I'm going to repeat that. Design for failure and nothing will fail. This architectural pattern will change the way you design, build and deliver systems. And it will change the experience that your end users have in using your systems. Because suddenly a server going down won't matter. A load balancer breaking won't matter. A security exploit taken advantage of won't matter because you can recover transparently, automatically, and without the end user knowing it's even happening. It is an incredibly powerful and game-changing technique. And one of the reasons why we can do this is because we're taking advantage of some of the many benefits that we all know about now about cloud. And that is because we don't have to have the big upfront capital expense to have extra nodes to use when I need them. I don't have to pay for my DR unless I'm actually using it or testing it. I can deliver very scalable fault-tolerant applications that can survive the loss of hundreds of nodes if I want to, just by building it in an elastic fashion. And I can improve my time to recovery by shielding my end user from some of the muck and processing that goes on in all that high availability work. So let's talk about some strategies and some building blocks. So obviously there are a lot of services that we provide from AWS that hopefully many of you like to use, and some of them are inherently by design fault tolerant or highly available. Things like the simple storage service, DynamoDB, etc. are already built and managed for you. So you don't have to worry about those. Point to your endpoint, do correct error handling, you should be good to go. However, on the compute side, EC2 and the storage side and the database side, you still need to practice some processes and procedures to make sure your application is highly available. Now, when doing this, in any case, you work through this stack. It's kind of like the Star Wars thing going up there, isn't it? But essentially you have geographies. Where am I going to put stuff? Facilities. What big buildings will I put my things in? Networking. How do I connect my things? Configuration. How do I get them to actually work? Management. How do I run my stuff? Deployment. How do I put new stuff out there? And then resources. What is my stuff actually doing? And this all translates into various concepts within AWS. We have regions, we have availability zones, we have alarming, we have a whole lot of stuff that I'll take you through step by step, and we'll examine what we do at each layer. Firstly, regional diversity. There are multiple regions, use them, but use them for the right reasons. So multiple regions are used typically to provide closeness to your end users. And the first question I always get is, we don't have a region in Australia, what do customers do? Well, let me give you the answer. Customers typically use two regions when they're servicing customers in Australia. They'll use Singapore or they'll use US West. They're the two that they get the most success out of. If you're going to Singapore, you'll typically get about 100 milliseconds if you're on Optus. If you're going to US West, you'll get about 180 on Telstra, roughly speaking. However, we have customers who are servicing global marketplaces. They have instances in EU, they have instances in US East, they have instances in Tokyo because they're servicing their local market. So you can use this to build up a global footprint where you're reducing your blast radius of if something goes wrong. But the main focus is on availability zones. You can think of availability zones as separate, logically separate and physically separate constructs. They have separate power feeds, separate network feeds. They're in separate facilities. But they're only useful if you use them. So when you're designing your application, you should be deploying across multiple availability zones in such a way that a loss of a component in any availability zone does not cause the application to fail. This is very important. Now, you don't have to do this during dev and test. You may look at that and say, yeah, that's a lot of servers going on there. Well, you don't need them in dev and test. You don't have to have them, don't have to buy them. But once you come to a production rollout, you should be deploying in a diverse way across availability zones. And I'll show you the all singing, all dancing version of that shortly. At the network layer, there are a few things that we can do to be fault tolerant. Now, you can see this address on the left, the 107 dot address. It's not fault tolerant, it's just an address. The 50 dot address is highly fault tolerant. How can that be? Well, it's an elastic IP address. An elastic IP address is an IP address that you can attach and detach from an instance. So if that instance fails, you can have another one running and immediately attach it to it. It takes a second to reattach it. As far as your end user is concerned, they're hitting exactly the same endpoint, but everything behind the curtain has just changed. If you're not familiar with the Elastic Load Balancer, please become familiar with it. The Elastic Load Balancer allows you to divide load amongst multiple nodes across multiple availability zones, whilst also maintaining health checks amongst all those nodes for you. So it knows where to send the traffic. It knows what's alive. And many of you have said for a long time, I'd love to use ELB, but it doesn't work in VPC. It now does. So if you didn't know that bit of knowledge, you now know it. At a high level, if we're talking about cross-site failover, cross-region failover, we have the ability within Route 53, our DNS service, to programmatically make changes. So you can use rules like weighted round robin and say, my production site is 100, my DR site is 0. When I declare a failure or my sensors determine a failure, I will programmatically go to the API and change that weighting. So now all my traffic goes to the other site. No human involved. You now can also use latency-based routing for this to have it happening all the time if you're servicing different customers. There's another new thing that's only available in VPC, Virtual Private Cloud, which is called the Elastic Network Interface, ENI. This is a really interesting concept where what we've done is separated the life cycle of the network interface from the life cycle of the instance. So the instance can be terminated and the network interface maintains its state and is alive still. So this can be used for what we sort of call poor man's DR. Here we have a web server in the middle there. You can see on the, I'll just face this way, On your right-hand side, we have management traffic going through Ethernet 0, it's a private address. And on your left-hand side, we have our public IP that we're driving traffic to. If that node fails or I wish to replace it, why would I replace it? My security has just been compromised. I've been hacked. I'm in big trouble. I have no idea how forensically I'm going to clean up this instance. Well, I'll give you the easiest guaranteed way to clean up that instance. Terminate it. Terminate it. Start up a new one from a fresh AMI that you know is clean. Patch it as it should have been patched in the first place. Attach it to the Elastic Network interface. Good to go. Very powerful concept. Now, what about building my stack? There's plumbing involved. I've got to build security groups, I need to attach elastic IPs, I've got to choose subnets, I've got to do which instance size I'm going to use, I've got to create auto-scaling groups, I need to create alarms, etc., etc., etc. You don't have to do this manually. You can use CloudFormation. CloudFormation will actually let you script up, using human-readable script that you manage as code, the entire stack that you have. You can even build your stack in advance and use CloudFormer to reverse engineer that stack and say, how would I build this if I had to build it again? This is incredibly powerful in terms of building dev and test environments and also standing up complete new environments in a duplicate. So I encourage you to look into this a bit more. It's really cool. Now, the other thing is that, you want to set the temperature, not be running the furnace. So what do I mean by that? Well, it's pretty obvious that the guys on the right are doing a hell of a lot more work than the machine on the left. And if any of you have done shoveling and sweating like that, which I think many of us have from time to time, it's not fun. So you don't have to do that. You don't have to manage how many nodes am I running, how much load is going here and there. What you use is a combination of services. CloudWatch, alarms, and auto-scaling. CloudWatch is the service that works by default on most of the resources you already create in AWS, gathering statistics. For free on a 5-minute basis, cost basis, it's on a 1-minute basis. And it maintains that information. Could be CPU utilization, could be memory, could be disk, could be whatever. You can then set alarms around those metrics. When my web server farm is running at 80% CPU utilization for more than 5 minutes, add 2 nodes. That's what auto-scaling does. It knows which nodes to add, how to build them, where they need to come from. Now, often I get the question of, I can't see auto-scaling in the GUI. It's not in the GUI. It's command line only at the moment. So just be aware if you're looking for it, it's not going to be in the GUI. But it is an incredibly powerful availability technology because you can do really cool things. This is the I don't have to wake up at 2 in the morning rule. If I have one node that I'm running that's doing some sort of function, I can create an auto-scaling group with a minimum of 1 and a maximum of 1. 1 shall be the number and it will only be 1. So if that node fails at any time, it'll start right up again. I'll get a new one. I don't get woken up. The idea here is to say, nodes will fail, things go wrong, bad things happen. It is much better to be fixing them and resolving the problem at 10 a.m. in the morning with all your team around you with a nice cup of coffee after a good night's sleep. Because everything else just spun itself back up again overnight for you without having to be involved. It's a lot worse to be golden screwdrivering something at 2 in the morning. Excuse me. So how does this look? Let's forklift an application. Let's take a traditional 3-tier application. We've got web instances, we've got app instances, we've got a database, and we just dump it in one availability zone. Highly available and fault tolerant? No. So what would we do? Well, we would firstly make sure we deploy across availability zones. And we would drive that by using the Elastic Load Balancer to divide the load evenly across those zones and check the health of the web tier. At the web tier, we put in place auto-scaling rules that automatically know how big or how small the farm needs to be given your criteria. Again, it doesn't go out of control. These are your criteria. You set the minimum, you set the maximum, you set the desired size. And you set the rules as to when things change. So rules can be workload-based. I'm struggling, give me more nodes. Or it can be time-based. I call this the today to night effect. Today to night effect works of so and so. You get the call from marketing, we're going to be on today tonight. It's fantastic. Everyone's going to be hitting the website. I'm in trouble. And essentially what happens is you know that the tsunami wave is coming and you can't do anything about it. With autoscale, you can set time-based rules and say at 6:30 tonight, spin up 40 new nodes. And then at 8 p.m, shut them down. That's the power of autoscaling. You're not involved, you're setting that temperature. You're not driving the furnace. Then we have software load balancers in play in the middle there. We want to decouple our application as much as possible so that failures in any components do not affect upstream and downstream components. Very important. Then we have similar auto-scaling groups at the app tier, based on the rules around that make the most sense. There may be rules that you would like to insert, such as number of connected users or other types of metrics. You can publish custom metrics from within your instances to CloudWatch, which can then trigger alarms, which can then run the auto-scaling groups. So you get this very nice inductive cycle going on that you can build exactly how your application needs to work. Then at the database layer, what have we done there? Well, firstly, we'll put some caching in front of it. We've used Elasticache, which is hosted memcached. It's not in itself highly available per se. Its job is to buffer the workload of the database. A database that's not working so hard has less of a tendency to fail, certainly in my experience. But at the database layer, we need some robustness. We need to control our single point of truth. So we use the relational database service. And this allows us to implement synchronous replication between the master and the secondary node with a common endpoint. So all the application has to do is talk to that endpoint and it will get a database. It doesn't care which availability zone it's in. And that's synchronous replication for both MySQL and for Oracle now as well. We recently released RDS for SQL Server. It's not replicating that at the moment, but you can imagine it will be over time. So what if I don't want to do all that, and I'm a PHP developer, or I'm a Java developer, or I'm a .NET developer? I can use Elastic Beanstalk. Elastic Beanstalk allows you to deploy your code into some parameters and have all those rules and things created for you. Now, many of you are going, oh, that's cool, let's go. I will warn you, at the moment, it's only available in US East and in Tokyo, but it is rolling out globally. But it is a very interesting option for people who wanted to have the deployment stuff taken away, but still want access to all the underlying pieces. You still see all your hosts, you still see your load balancers, you see everything. But this just takes away some of that work for you. Now, at a fundamental level, one of the key things that we use in Amazon is the Amazon machine image. These are golden images upon which you build your instances. It is very important to maintain your AMIs. We maintain the ones that we have in the catalogue, so when there was a recent Windows RDP exploit, we patched all of ours straight away. But if you've got your own, you need to be patching as well. Very important. There are also other alternatives like Chef and Puppet and CloudFormation init, where you can build things in a dynamic fashion. Also, when you're building your AMIs, by default, I recommend, unless your application demands it, go 64-bit. Because we now have 64-bit across the fleet, which we used to not have. So now you can deploy 64-bit apps anywhere you want. But I want to lead you into a concept that is very powerful, bootstrapping. Who's familiar with bootstrapping? Yeah, a few people. Bootstrapping is one of those things that some people have heard of, some people do, some people have never heard of it. Bootstrapping lets an instance ask and answer a very simple question. Who am I and what do I do? Now, if you think about it conceptually, if an instance can ask that question and answer that question, I don't have to touch it anymore. I don't have to worry about deployment, patching, physical interaction. It will come to life and do something and be useful for my application. So there are three major approaches to this. It's a continuum, but I want to share three major approaches. And hopefully I won't make you too hungry because it's a bit of a pizza analogy here that we're going to work from. We can have our frozen ready-made pizza that we just take out, our fully baked golden image. We can have our frozen pizza base where we add a bit more to it, or we can have our complete custom-made version. So let's step through those. In the frozen pizza model, I know all the bits I'm going to need. The operating systems, the application binaries, the additional helper modules, the libraries, my code, and I'm just going to stamp that sucker out. And once I stamp that sucker out, I'm going to be building instances like nobody's business, and it's just a complete package. Now you can implement this as part of your development tool chain so that your output is a fully baked AMI. This is what Netflix does. They've publicly talked about this on their blog. Their whole tool chain is engineered that this is the output. Boom, fully baked server. One way of doing things. Benefit of this approach, boots really fast, has everything on it. Downside of this approach, more maintenance if you need to do a change. You've got to go through that whole cycle again, don't you? Let's look at the frozen pizza-based model. I know I need to have certain binaries and certain applications always available. I just use them all the time. So I load them onto my AMI and have them there all the time. But at boot up time, I'll reach out somewhere, could be S3, could be somewhere else, to get the additional components. to download them, install them, run them. Or I may patch to the latest versions of those particular applications so I don't have to rebuild my AMI. And then I can stamp out my instances again. The third option, which is the made-to-order pizza, basically I have my operating system and I have a client of some sort that's going to talk to some master orchestration tool. Could be Chef, could be Puppet, could be any number of tools. And when I start up, I go and download everything I need. And I can build myself automatically every time. And then I can just stamp out more combinations as I go. Now you may say, which is the right one for me? There is no right one. All of them have different benefits and challenges to them. And in many cases, I see customers mix and match. So if you've got a database, you may go with the middle version, where the database is always installed, it's there, you're just patching it and going for gold. If you're in a high-powered, quick development environment, your web servers and app servers may build themselves completely from scratch. It's totally your choice, but you mix and match in the environment as makes sense. As I mentioned before, these instances have immense power. An Amazon Web Service instance can accept user data. It can accept about 60K's worth of user data on startup. And it can access it from within itself. It can self-reference itself. What does that mean? It means I can pass instructions to the instance at boot time to go and do things. In this example, we're saying, hey, go install some packages and configure yourself. Get on with it. I could pass parameters to say, go build yourself a particular way. I could pass information to say, go tag yourself a particular way in the console. Suddenly I have the ability to give enough information for it to do something useful, to be self-configuring. So if you tie this concept together with the auto-scaling concept, I have this self-managing automated fleet that can build the latest version of code whenever I need it to, in the correct sizing that I need it to, at any one time. This is a game changer. When you wrap your head around this from an architectural perspective, you sit there and say, wow, I can build some pretty cool stuff now. And I can build it to be resilient and robust as much as I need it to. Because if I lose a node, I can spin 10 more up straight away. And I'm totally confident it'll be built correctly. We talked a bit about the database before. I want to reiterate the database. Make sure you use replication. Make sure you're using multi-AZ replication. Very important to make sure you have that protection. If you choose to roll your own database, do replication. So remember, in Amazon Web Services world, you can deploy any database you like on an EC2 instance. All RDS does is takes away some of the undifferentiated heavy lifting of configuring the server, laying out the storage, doing the backups, doing the clustering, etc., etc., etc. So for many people, this is very appealing because it just makes life easier. But please use the tools that are available. Similarly, you can use read replicas. Now, read replicas are not by default for high availability. But again, what they do is they alleviate load on the primary database. A read replica sends data to other nodes that are used for read-type traffic. So your primary database is only accepting writes. So it reduces the workload on that database and lets you tune it appropriately for the traffic that it's doing. So read replicas are automatically created for MySQL with RDS, and you can have up to 9 of them. So that's the use case for that one. So we talked about testing. Test aggressively. Break stuff. It's a lot of fun. Don't do it, in the middle of the day when everyone's expecting to use the system, but you've got to do things in an aggressive way. You should be able to remove components from the system regularly. Many of you would have heard of Chaos Monkey, which is Netflix's version of this sort of active testing. And the good news is towards the end of the year, they will be open sourcing the tool. So anyone can use it. Now you may not use the tool as it is, you may just take the concepts and ideas from it. Similarly to what we talk about in terms of game days at AWS. What happens if I shut down the primary database arbitrarily? Do I really know? Am I confident? Well, we'll find out. I'm going to instrument the hell out of everything. I'm going to see exactly what went wrong, but I'll fix it. Or I built my application such that I think that I can lose 3 web servers and it's still going to work. Well, lose those servers. Terminate, terminate, terminate. Let's see what happens. Very important to test aggressively. This should be built into what you do. In general, things won't break if you built them the right way. But again, if you design for failure, nothing will fail. So you've got to assume everything's going to break. Everything will break. How do I get around it? That thought process changes the way you design things. And it also changes the way you test things. Too many times in testing, I've seen people say, that'll never happen. And many of you in the room know that's what always happens, is the thing you say will never happen. Bad stuff happens. Usually on about a Saturday night, about 11 o'clock is about the best time for that to happen. So let's pivot a little bit and we'll talk a bit about security, because everyone loves to talk about security because it's so exciting. You've seen Steve talk a lot about security, and I'll reiterate some of the things, but I just want to share with you something that happened recently. So I went through a customer call recently where we talked about all our certifications. They took me through the ringer, which I invite any customer to do so. They want to know about our ISO accreditation and how we secure our sites and who can access what systems, and is it true you can't access our data, and what about getting into guest machines? No, we can't get into the guest machines. And do you really shred the drives? Yep, they get shredded. You can't buy them from us, etc., etc. We have management things against DDoS attacks, etc. We do all this really cool, difficult, important security stuff. And then I said, what about your application? How do you secure your data? What are you doing with it? We take orders from customers and we send the orders out to the customers. So that's interesting. And I assume you're encrypting that customer data. No. Ouch. Don't leave the gate open. There is no point looking at all the cool stuff that AWS can bring for you from a security perspective if you forget from the guest operating system up. Security has to be built in at every single layer all the way along. And I'll challenge you right now and say, if you are hosting on premises, it should already be built this way. Don't believe in the M&M principle of security, the crusty bit on the outside and the sweet, soft interior. That's what we elude ourselves into thinking that we have, where we have, oh, there's my site over there, I'm securing it, it's fine. I've been in that many data centres, I live in Melbourne, I've been in that many data centres in Melbourne at 2 o'clock in the morning, unescorted, able to do whatever I want. Banking sites, government sites, I've been there. Now, I'm an honest person, I don't do bad stuff, but you know what, if I wanted to, I could have caused havoc in there. What the hell was I doing there on my own? But no one else wants to be there at 2 in the morning, I'm there, I'm doing some work. Don't be deluded around security, be active with your security steps. So what are some of the things you can do? So the first thing is to use identity and access management. This allows you within AWS to create groups and users that have specific control and capabilities in the environment. Now let me position what this is used for. This is used to provide permissions to the API, to the control plane of AWS. If you have users who just need to log into servers and systems, they don't need any access to AWS to do that. You secure them like you normally would, Active Directory, other LDAP tools, etc. This is just for users who need to control resources within AWS. So here's another tip. Remember I was talking about that automation piece. In many cases, the bootstrapping and automation might want to reach out to a resource in AWS. It might want to go to an S3 bucket. It might want to do some tagging on a host. You create a user, a system user for those tasks that are individual. You can have as many of these as you like. An individual user that is locked down in terms of its security capability to only do that task it's doing. So if you have a script on your host that can tag itself with data, the only API call it can make is the tagging call in EC2. This gives you security. If you have users that are logging on to maintain your systems, operational staff, etc., use multi-factor authentication. You can add this to all of your users now. In the past, we only allowed the physical device you had to pay $50 for. Not a great solution. None of us like hardware devices. No longer, no more. You can now use virtual devices, OAuth type devices. So Google Authenticator is one that I personally use. Works great. You can manage it and maintain it yourself. This means that changes that are made need that multi-factor authentication. You can take it even a step further with what's called S3 Secure Delete. You can say that no one can delete an object from S3 unless they use the multi-factor authentication tool. Pretty cool. Some people take that even further and say no one can delete an object from S3 without using the multi-factor authentication, and we're not allocating a multi-factor authentication device. You ain't deleting it, it ain't going anywhere. So a nifty way to really worm your data. When you're building firewalls, it's important to have a tiered approach. So here we've got a 3-tier application. Our web tier, we're opening port 80 and port 443, HTTP, HTTPS, to our web server, to the world. We want everyone to access it. But the only ports that can be accessed on the app tier is traffic coming from the web tier on a specific port. If I want to manage that particular server, I can by logging in from my corporate network, because I've specified a particular address range that I'll accept and a particular port that I accept. Or I can come from another host, which is called a bastion host, which I can log in from. Then finally, my database tier can only accept traffic from the application tier or can replicate from the on-premises database, again, from a particular address. No one else, nothing comes in, none shall pass. This does not mean you don't use intrusion detection or intrusion prevention. It does not mean you don't use typical good security at your guest level. This is an additive level of security, but very powerful. Do use it. There are other tools like Direct Connect if you don't want your data to traverse the internet for some reason. The most popular one is the virtual private cloud, where you can create an IPsec tunnel between your corporate data center and the Amazon cloud. You can control things like subnets, access control lists, and the like. And of course, if you don't like sharing with others, some of us don't, you can have dedicated instances. A dedicated instance means that your virtual machines will only go on your hardware, no one else's. They don't mix and match. But in the cloud, security is a shared responsibility. There are three main components. There are the things that we provide to you and that we do. We do the infrastructure security and we secure the services. But the application security is still up to you. You can't outsource risk. It's all up to you. Make sure you use the tools and take advantage of those that are available to you and pay attention. That's really the main thing with security, is paying attention all the time. So a lot of information, a lot to digest. You may say, where do I go from here? How do I get some of this information? We have this great microsite on the AWS site called the architecture page, and that's where there are these really good blueprints of common design patterns. So patterns like web server across multiple availability zones, elastic MapReduce jobs, pipelining jobs for doing asynchronous processing, photo sharing sites, media sharing sites, very high-level useful diagrams and guidance of how to build these things. Also best practice guides about creating loosely coupled designs and applications, about securing your application, etc. So I recommend that you visit that site. So now we're at the point of Q&A. I think Joe's got the microphone and he's got t-shirts in hand. So please invite any questions.